Welcome you all students. I come up with a question. Here I just going to solve this question by using impulse momentum equation. Two blocks A and B of weight 60 Newton and 40 Newton are connected by a string. 60 Newton and 40 Newton which is connected by a string and passing through the smooth pulley. This is the pulley and this is smooth. There is no friction force on the pulley as shown in figure. Find the velocity of the block after 3 seconds, starting from the rest, and also find tension. Okay, so given data, the weight of the block A which is given as 60 Newton, weight of the block B which is given as 40 Newton. Okay, so if you want to find out the mass at A, 60 divided by 9.81. 60 divided by acceleration due to gravity. So here you get 6.116 Newton, and if you take mass at B, then 40 divided by 9.81, we just converting it into kg. Okay, kg, mass is in terms of kg. So here you may get 4.077 kg. Okay, in terms of kg. Fine. What about any other details given in the question? The time is given which is 3 seconds, and here it is given starting from rest. So definitely the velocity at the initial must be a 0 since it is rest. Okay, to find the velocity and the tension in the string connected. Both the things we need to find it out. Solution: first, just like previous model, identify the free body diagram for the block A and block B. If I consider a block A, it has self weight which will be directed downwards, and it has a tension force since it has the string which will be just outward from the considered point. So here it will be similar fashion. If you consider this is a block A and block B, if you consider it, it also has its own weight which is 40 Newton, acts downwards, and the tension force from it will be just outward from the considered point. Both the tension will be equal in magnitude, so I have considered as T, right? I am not just differentiating it. Fine. So both the things, block A and block B, has only one unknown force which is T. So any one of the block we can consider since it is equal. So here I just going to consider a block A. If I consider it, look at this block A where the motion will happen. Since the weight is heavy on the block A, the motion will be downwards. There is no doubt at all. Here the weight is heavy, so it will be moving downwards. So if it moves downwards, here just like previous one, that is energy equation. Okay, energy equation, we need to take the things, that means summation of V and summation of H based upon the motion. That means if the motion is just downwards, it says sum of vertical force which is not equal to 0, because the vertical force is not in equilibrium. That's why it is moving downwards. If it is in equilibrium, definitely it will be at a particular place. Okay, so here I just going to take sum of vertical force is not equal to 0 since the motion is vertically downwards. Okay, so if you take something like this, here when you are considering the forces, you must be very clear the previous one and this one, that means conservation of not a conservation of energy, which is the energy equation and the impulse momentum equation, the sign must be directed, that means if this direction of the force is just equal to the motion, then it will be positive. So here the motion is downward, so downward force has positive sign, the upward sign has the negative sign. Okay, it's based upon the motion we have to take. So here, if I apply sum of vertical force is equal to 0, what is happening? We just want to look into it. Okay, so sum of vertical force, which is equal to T which is a upward force, so minus, and 60 Newton which is downward force, it carries positive sign 60. Okay, let it be. And then what you have to do is just apply impulse. It's a impulse momentum equation, right? So just have an details for impulse. Impulse is I, which is equal to F into T. So here force is just a vertical force, right? All are vertical force. So here summation of V into T. So it will be minus T plus 60 into T. So this is the impulse. So here minus T plus 60, the T value is here, which is 3 seconds. I just gonna take something like this. And the next one, identify the momentum. It's very important. M is equal to M mass into V minus U, right? Here the mass at the body or block A, so MA. So mass at A, which is 6.116 into V value, that means final velocity is the unknown one, we need to find. V minus initial one is 0. So we may get momentum 6.116 into V. Okay, right. So hereafter what we can do is just we can move to the next block. Consider a block B. So here where the motion is, when the 60 Newton block just comes down, sure this block B will be moving upwards since it has a low weight. Am I right? So the motion is downward. The motion is upward here. So that I can say, and here the force acting is a vertical one, and since the motion is upward, sum of vertical force which is not equal to 0 in this case as well. And when you are considering this sign, here the motion is upward, so that the upward forces should be considered as a positive sign and downward force needs to be considered as a negative sign. I already taught you, purely you need to take the sign when you are taking the forces, it must be with respect to the motion. If it is moving equal to the motion, it must be positive. If it is just moving opposite to the motion, then it will be negative sign. So that's how we have taken here. So now sum of vertical force is not equal to 0. I just going to apply. So sum of vertical force which will be equal to, the vertical forces are T and 40. So upward force is a positive, so T minus 40 Newton. Okay, fine. So now just identify impulse. So if I identify impulse here, I is equal to F into T. So that means sum of vertical force into T, here I will get T minus 40 into 3 seconds. The similar manner momentum. Be ready with the momentum for this block B. So when you are considering it, M which is equal to M into U minus, sorry, V minus U. Here U is equal to 0. What you will get? Momentum at the block B, right? Block B, momentum at block B, the mass is 4.077 and then into V. This is the momentum. Have you got it? So after finding it, the each blocks A and B, the impulse momentum, okay, what we have to do is we need to identify which will in total, so that you can get the velocity of the string or velocity of the moving block. Okay, so here I just going to apply impulse momentum equation. So total impulse which is equal to total change in momentum. Total impulse in the sense we must add both the block A impulse and both the block B impulse. So if I consider this as block A impulse is here minus T plus 60, am I right? Both the impulse we need to add it off. So plus here the impulse at the B which is T minus 40 into 3, which is equal to total change in momentum. Both the things we need to add. The momentum at the block A which is 6.116 into V plus 4.077 V, which is the momentum for block B. Both the things just add it off, something like this. When you just equate it by just taking the T terms one side and keeping the V terms another side, we can just get the value for V actually. So when you simplify it, I can say minus T plus 60. Both the terms see here we have 3 common. So commonly I just going to take the 3 so that the simplification will be easy. So minus T 6 plus 60 plus T minus 40 into 3. Have you got it? I just taken this 3 as a common. So now see the TT get cancelled. So here comes, if you add it down, you will get 6.116 and 4.077. It may be around 10.193 velocity. Okay. So now you may get here it is 40. If you minus it, 60 minus 40, you may get 20 into 3, which is equal to 10.193 velocity. Okay. So now the velocity can be easily identified. Just divide 20 into 3 divided by 10.193. We may get 5.863 meter per second. Velocity unit is meter per second. May get in such manner. Okay. So here the velocity of the block after 3 seconds is identified. The next thing, we need to find the tension force T. So in order to identify the tension force, what we can do is we just consider any one of the impulse moment equation. Okay, that means any one of the block A impulse momentum equation. I just going to apply to find T. I just going to apply impulse momentum equation in block A. Okay, I just going to apply in the block A, or else I can apply in the block B. In any one of the block we can apply it. So I just going with the block B. Okay, So if you apply it here, the impulse momentum, in the sense impulse which is equal to change in momentum, right? This is the equation. Impulse which is equal to change in momentum. So that here it will be impulse is t minus 40 into 3, which will be equal to 4.077 into v. So the velocity value already it's been identified. If you multiply this 3t minus 40 into 3, which is equal to 4.077 into 5.863 will be the answer. So from this we can just identify the t value, which is easy. Now if you take 3t, which is equal to 4.077 into 5.863 plus 40 into 3, and if I do one more simplification, just multiplying this 3 in the denominator, you may get the answer for 3t. You will get 48.0045 in terms of Newton. Tension is a force, so you may get in terms of Newton. So I have found the velocity and tension. I hope you understood how we need to work when you are having such question by using the impulse momentum equation. It's so easy. Just identify the free body diagram for each one of it, and afterwards identify the impulse and momentum for each blocks. And we must consider, when we are considering the forces, we must see in which direction the motion is. If it is directed towards a vertical, then the vertical force will not be equal to 0, since the motion is happening. Okay, it says it's not in equilibrium. Okay, in such manner I have taken it. And the thing is, if the motion is towards downwards, then you have to take all the force acting towards downwards should be a positive one, and which is moving upwards should be a negative one. So in such manner we have to solve each and every one, and after finding it the separate impulse and moment, just find it in total. So total impulse, which is equal to total change in momentum, in which we have to add everything. If you have 3 blocks, we need to add 3 blocks momentum and 3 block impulse, something like that, so that you may get the unknowns. So here we need to find out the tension. So for that I have considered one of the block, that means block B momentum, impulse momentum equation. So by taking it, I got the answer for tension. So I hope you understood how you need to work when you are having the impulse momentum equation. Okay, thank you so much.